Here's problem 2225. One end of a copper rod is in thermal contact with a hot reservoir, T of 500 K, and the other end is in thermal contact with a cooler reservoir, T of 300 Kelvin. Find the entropy change of each reservoir and the total entropy change when 8,000 joules of heat energy are conducted from one end of the rod to the other with no change in the temperature distribution in the rod. Alright, so we're going to imagine that we're going to have two entropies here, both of them occurring at constant temperature. For the hot end of the rod, our entropy change is going to equal our heat added from the hot end over the temperature of the hot end. In this case, though, we're going to be losing heat, so that's going to be a negative value for the heat added. In other words, we're going to be losing 8,000 joules of heat from the hot end, and this is going to occur at 500 K. So this is going to be 80 divided by 5, or negative 16 joules per Kelvin for that entropy change. Entropy change at the cold end is going to be our heat exchange over that temperature, and we're going to be receiving that heat, so that would be a positive 8,000 joules occurring at 300 degrees Kelvin, and that is going to be 80 divided by 3, or 26.7 joules per Kelvin. So our net entropy change is going to be the entropy change of the hot reservoir plus the entropy change with the cold reservoir. That's going to be minus 16 plus 26.7, which will give us 10.7 joules per Kelvin. So we have a net positive entropy change for this whole system of 10.7 joules per Kelvin, making it likely that the heat exchange will go from hot to cold.